This is an analog computer. It adds two numbers together by rotating two input wheels. The rotation of each wheel is an analog to the numbers we want to add. Now the interesting thing is, it doesn't use any circuitry. It doesn't alternate circuits between on and off. A digital computer would take around 50 transistors to do the same calculation and would take on the order of 1,000 transistors just to multiply, whereas we can make an analog circuit by passing a current through a resistance and the laws of physics does the calculation for us. We stopped using machines like these 70 years ago because they're single purpose and exact. Information stored in binary can be used to represent text or even images, whereas a machine like this can only do one thing, and even then it can't accurately add two numbers together because it depends on how accurately we input the values. But analog computers are blazingly quick, and they're making a quick resurgence in the field of AI. When an AI identifies a shape, it takes in a bunch of inputs, like the brightness of each pixel. It then multiplies these inputs by individual weights, which are adjusted as the AI is trained. The AI figures out that this is a triangle by multiplying each input with its weight and then adding all of these values together, which is something called a matrix multiplication. Since analog computers add and multiply far more efficiently, analog chips could be used to provide AI functionality at a fraction of the cost and power of digital chips. In a few years' time, perhaps we look back on digital computing not as a final evolution in computing, but as a starting point.